All right, let's talk about something that could genuinely change the game for how AI works. It's a new standard called the Model Context Protocol, or MCP. And its goal is really simple, but also absolutely massive: to connect our AI models to, well, everything. But let's start with the feeling I bet you've had. You've got this incredibly smart AI, right? It can write poetry, it can code, but then you ask it to do something simple, like check your calendar for an open spot or find a recent file, and nothing. Why does this powerful technology still feel so trapped, so cut off from the real world where it could actually be useful?
Okay, so let's get into it. The reason our AI feels like it's in a box is because it's constantly running into three fundamental walls that keep it isolated.
First up, you've got the knowledge cutoff. The model is basically a snapshot in time. It has no idea what happened yesterday, let alone 5 minutes ago. Then there's the isolation problem. It literally can't see or touch your personal apps, your data, your calendar. And when you combine those two, you get the dreaded hallucination problem. Without real-time, factual data to work with, it just starts making stuff up.
So, how do we tear down these walls? This is exactly where the Model Context Protocol comes in. And the beauty of it is, it's not some impossibly complex piece of technology. It's a really elegant solution that's built on a simple but huge idea. And honestly, this is the perfect way to think about it. People in the know are calling MCP the USB-C of the AI world. Just let that sink in for a second. Imagine a single universal standard where you can plug any tool, any app, any data source into any AI model, and it just works. No fuss, no custom adapters. That's the dream.
Because right now, the way we do things is a total nightmare for engineers. You have M number of AI apps and N number of tools you want to connect them to. And to make them talk, you have to build a unique, custom integration for every single pair. It's this M times N spaghetti mess that's fragile and incredibly expensive to maintain.
And this is where MCP just shines. It takes that chaotic exponential problem and turns it into a beautifully simple, linear M+N connection. A tool developer just has to build one connection that speaks MCP. An app developer does the same. And because they're all speaking the same universal language, everything can now talk to everything else.
Okay, so that's the big picture, but how does it all work under the hood? The best way to visualize it is like a three-part harmony, with three distinct players each doing their specific job to make the music happen.
First, you have the host. This is the conductor of the orchestra. It's the main app you're interacting with, and it's in charge of the big picture: security, user consent, and pulling all the information together. Then you have the client. Think of the client as a dedicated messenger that has one job and one job only: to carry a request to a single destination. And that destination is the server. The server is the specialist. It could be your Google Calendar, your GitHub repo. It's the expert that actually knows how to perform the task. So let's trace a simple request. You ask the host, hey, find a time for me to meet with my team next week. The host, our conductor, knows this is a calendar job, so it hands the request off to the calendar client. That client zips over and talks only to its dedicated calendar server. The server does its thing, checks your schedule, finds the slot, and sends that result right back up the chain. It's clean, it's secure, and you can see every step. Now here's a really key point. MCP is way more than just plumbing to connect systems. It's creating a brand new, structured language for AI to use. It defines the rules of engagement, which gives us incredible control over how much autonomy and power the AI actually has. At the highest level of autonomy, we have tools. These are actions the AI can decide to use all by itself. So if you just say, schedule a meeting, the AI can reason, okay, to do that, I need to use the Find Available Slots tool. You don't have to tell it the steps, it figures it out. It's proactive. Now take a step down in control, and you get resources. This is different. The AI can't just decide to go grab a resource whenever it feels like it. You, the user, have to explicitly give it the resource, like dragging and dropping a PDF into the chat. The AI can read it, analyze it, and use that information. But, and this is critical, it cannot decide to go rummaging through your file system on its own. It's a much safer way to provide context.
And at the most controlled, most predictable level, you have prompts. Think of these as trusted, pre-built recipes for common tasks. The user has to trigger them directly, maybe with a slash command like /create GitHub issue. When you do that, you know exactly what's going to happen. It's reliable and safe. So what does this all mean when you compare it to older methods like function calling? Well, traditional function calling is what we call tightly coupled. The AI and the tools are all locked into the same system, which often leads to vendor lock-in. MCP completely flips the script. It is fundamentally decoupled. It allows for a truly open, interoperable ecosystem where any AI can talk to any tool, no matter who built them.
So where is this all headed? An AI that's connected to everything sounds pretty incredible. But as we look toward that future, we have to be clear-eyed about both the immense promise and some pretty significant peril.
The promise is just huge. We're talking about true standardization across the industry, a modular and scalable way to build AI agents, and of course, AI that is just vastly more capable because it's finally grounded in your real-time data. And importantly, it's being designed from the ground up with security and transparency in mind.
But we have to be realistic about the hurdles. The protocol is brand new, so the ecosystem of tools is still growing. There's also a tricky technical problem. If you give an AI too many tools, it can actually overwhelm its limited memory, or context window. But the biggest challenge, the one that is the most significant hurdle to adoption, is security.
And these security risks are not just theoretical. They open up entirely new ways for bad actors to attack. We're talking about things like indirect prompt injection, where an attacker hides malicious commands inside a document that you feed to the AI, or tool poisoning, where a trusted server gets compromised. And the really scary one is data exfiltration, where a single breach could become a keys to the kingdom event, potentially leaking all of your connected data.
And this brings us right to the final critical question. The potential for an AI that can truly act as our agent in the digital world is immense. The dream is right there. But it all, and I mean all of it, hinges on the community getting the security right. So I'll leave you with this thought. If we can solve this incredibly complex security puzzle, what will an AI that is connected to everything truly be capable of?